Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we'll continue further with Mathematics class 11th. The chapter that we're dealing with is sequence and series. And now is the turn of exercise 9.2. This particular exercise is based upon arithmetic progression and its related concepts. So along with the questions, we'll be seeing the concepts involved in this particular exercise, and obviously you'll be benefited with the concepts with the solutions of each and every question over here. The first question says, find the sum of odd integers from 1 to 2001. Okay. Sum of odd integers from this to this. So from here to this particular point, these two are also odd integers. We are supposed to consider these as well, right? So we have, let's say, the general method which says, okay, you have 1, then the next odd integer will be 3, the next odd integer will be 5, then you will have 7, and correspondingly you will continue up till 2001, and you are actually interested in the sum of this particular series, this particular sequence, right? Sum of this particular sequence, or when you form the series, the sum of that corresponding series. Okay, odd integers we have written. The formula, the important thing about arithmetic progression, let's note those things. So an in general is a plus n minus 1 d. Two things are important, the first term and the common difference. If you know the first term and the common difference, you can always find the nth term. The sum of first n terms, mind you, sum of first n terms, you have to start from a, right? Sum of first n terms, which is actually a plus d plus a plus 2d plus dot 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 plus a plus n minus 1 d. This is the expanded form, and this can be clubbed together to give you this formula. 2a plus n minus 1 d. How do you obtain this result? By simple modification. Basically, you write Sn directly straight, and you write Sn again by reversing the order of the terms, right? And you add them to give you this. This can also be written as n by 2 a1 plus an. What is a1? a1 is a. And what is an? A plus n minus 1 d. Adding these two gives you this expression over here. So this can also be written as first term plus last term. N by 2 times first term plus last term. That's another version of writing this formula. But do you see that for finding Sn, you need first, last and n as well. Even if you have first and last term, you need n as well. Or in this formula, you need first term, common difference and n. So the important thing is you are supposed to find n. And for finding n, we are given an. In the for an, do you see that a, d, n and an are involved, right? If you know a and d and you know an, you can easily find n from here. That's the important thing, first of all. So from here, I can observe that a is equal to 1, common difference is equal to 2, an is equal to 2001. Once I observe these few things in this sequence, I see that an can be written as a plus n minus 1 d, or I can replace an by 2001, a by 1 and n minus 1 times common difference, which is 2. So 2001 minus 1 will be 2000, divided by this 2 will be 1000. 1000 is equal to n minus 1, and that tells me n is equal to 1001. N will be equal to 1001. If that is the case, have you found n? Yes, we have found n. That's the number of terms in this sequence over here. Therefore, the sum of n terms can easily be found. Sn will be equal to n by 2, and now I can use a1 plus an easily because I know an directly. This is 1001 by 2. a1 is 1 and an is 2001. This is what you have, right? So what does that become? This becomes 2002 divided by this is 1000. This is 1001. 2002 upon this is again 1001. So this into this is what you get, 1001 square. Yes. And what is that equal to? Can you find that square easily? Yes. Just multiply them. So what does that take me? 1001, and then you have 0 and 0 being involved over here. So what you have over here is, let's see, 1001 000 and plus 1001. is what you need, right? What I've done is I've written this 1001 as 1000 plus 1, multiply this with 1000 and multiply that with 1 over here. So that gives me 1002001. That is my required answer for this question, as you can see over here. This is the final answer for this question. Yes, this is the final answer that's required for this question, as you can see over here. One important thing to note over here is, you've seen these formulae, right? Sum of odd integers, when you talk about sum of odd integers starting from 1, or sum of odd natural numbers starting from 1, if you talk about 1, 3, 5, 7, up till ... Let's say nth odd natural number, the nth term of this sequence will be 2n minus 1. If you have first n odd natural numbers, comma, sum of these first n natural numbers is simply equal to n square. This is something which you can remember. And do you observe that sum of first 1001 odd natural numbers is simply 1001 square? Yes. Can you derive that formula directly as well? Yes, you can derive that formula for this expression. Since there are n terms, so n by 2 is the sum. First term plus last term, 1 plus 2n minus 1 is actually 2n. n times 2n divided by 2 will be n square only. And that is something which you can remember for future, right? This is the complete solution of this question, and some extra concepts which we have discussed over here are covered, right? With this, we come to the conclusion of this complete solution for this first question. In the second question, we are given, find the sum of all natural numbers lying between 100 and 1000 which are multiples of 5. Lying between. Now the person has clearly mentioned lying between, right? So since the person has mentioned lying between, we are not supposed to consider 100 and 1000 because both of them are also multiples of 5. So what do we need? Sum of all natural numbers lying between 100 and 1000 which are multiples of 5. We need 105. We need the sum. For the sum, let us write the series directly. So the next term of this series will be, what will be the next term of this series? It will be 110, then you'll have 115, and correspondingly continuing further, just before 1000 you get 995. And once again, if you observe, you know A1, you know the common difference, and you know the last term, right? This is an arithmetic progression, and you know first term, common difference, and the last term. A1 is 105, this is A, common difference D is 5, and AN is 995. You know these three things. What else? Can you find AN? Because for finding the sum, I need N. AN is equal to A plus N minus 1 D. Let's apply this. AN is 995, A is 105 plus N minus 1 times common difference 5. And I can get the value of N from here, yes. 105 subtracted over here will be 890. 890 will be N minus 1 times 5. And what is the value of N minus 1 over here? That is 890 divided by 5. What is that? This is 1, 7 and 39 goes 7 times and 40 goes 8 times. This is what you have, 178. So N minus 1 is 178, which tells me N will be equal to 179. This is what you get. Is that okay? Yes. This is what you get. N equals 179. Sum of all these natural numbers Sn will be equal to n by 2 A1 plus An. This is first term plus last term, which gives me S179 will be equal to 179 by 2. The first term is 105 plus the last term is 995. What is the sum equal to? This is 179, which is okay, upon 2 is also okay, and this is 995 plus 5 will be 1000 plus 100 is 1100. This is what you have, right? Let's multiply these two and divide by 2 after that. So 11 into 9 is, there will be 2 zeros. 11 into 9 is 99. You have a 9. Then you have a 9 carried forward. 11 into 7 is 77. 77 plus 9 will be 86. Then you have a 8, 11 plus 8 will be 19 upon 2. What is that? This is 9, 8, 4, 5, 0. 98450 is the sum over here. The required sum, these numbers. And that's all that you have in this second question. The third question says, in an AP, the first term is 2 and the sum of first 5 terms is 1/4 of the next 5 terms. Very interesting. Show that the 20th term is minus 112. Okay. This is a proof that type of question. So in an AP, it is given. Some things are given. Let's write what is given. First term is 2. A1 is equal to 2. And the sum of first 5 terms, A1 plus A2 plus A3 plus A4 plus A5. This is the sum of first 5 terms. And can I denote it with S5? Yes. Is 1/4 of the next 5 terms. Next 5 terms will be A6, A7, A8, A9, then you have plus A10. Plus A10, and let's call this, what will this actually be? This will be this plus this. Had this been this plus this would have been S10. But if you subtract these, this is S10 minus S5 as per the formula of our arithmetic progression. So we have S10 minus S5, and it is given that sum of first 5 terms, S5, is equal to 1/4 of the sum of next 5 terms, which is S10 minus S5. This is what you have. Is that okay? Yes. Take a look at this carefully. This is given, right? What else? Show that the 20th term is minus 112. To prove. What are we supposed to prove? That A20 is minus 112. Now for A20, what do I need? I am already given the value of n, which is 20. I just need A and D, and do you see that I am already given A? Yes. If I am given A, I only need to find D using one more condition, and that condition is over here. Yes. So our focus is on finding D first of all. If we know D, if we can find D, we can easily write this. Okay. So let's use this given condition to get D somehow. Okay, S4 is equal to 1/4 times S10 minus S5, and that tells me, okay, 4S, just a minute, this is S5. This here is S5, not S4. 4 times S5 is equal to S10 minus S5. That tells me, okay, this is 5, S5 is equal to S10. And what is S5? S5 is 5/2. 2A plus 5 minus 1, which is 4D. This is what you have, right? What is S10? That is 10/2. 2A plus 10 minus 1, which is 9D. This is what you have. Is that okay? Yes. So 2 goes with 2, 5 goes with 10, 2 times. This is what you get. Okay. Let's multiply these together. 5 times 2 is 10A plus 5 times 4 is 20D, which is equal to 4A plus 18D. If you can observe, 4A plus 18D. What else? 20D, 18D, what you get over here is 2D, which is equal to minus 6A. Now A is 2. This is minus 12. And that tells me D will be equal to minus 6. That tells me D will be equal to minus 6. And since you have found the common difference, therefore A20, which is A plus n minus 1, which is 19, D will be equal to what? A is 2 plus 19 times minus 6 is what you get. And what does that give me? A20 will be equal to 19 times minus 6. Had this been 20 times 6, that will be 120. So this is actually 114 minus 114 plus 2. This is 2 minus 114. And what is this equal to? This is minus 112. So A20 is minus 112, and this is what we started with proving. This is what we wanted to prove. We have proved that. That's the complete proof of this question. If you see, if you write everything properly, your focus is clear on what are we supposed to find. What are we supposed to find? We're supposed to find the value of D in this equation. And using this equation we have found D. After that it's very easy to get A20 over here. That's the third question for us. In the fourth question we have how many terms of the AP minus 6 minus 11 by 2 minus 5 dot 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 are needed to give the sum minus 25. How many terms are needed, right? So in this given arithmetic progression, minus 6 minus 11 by 2 minus 5 comma dot dot dot. Can you identify the first term easily? Yes, A is equal to minus 6. Can you identify? It is given that this is an arithmetic progression, so common difference will be there, which is this, minus 11 by 2 minus of minus 6. A2 minus A1 or minus 5 minus this, that's also okay, right? So what will this be? 6 minus 11 by 2, which is 1 by 2. This is what you're getting. So you know A, you know D. What else? How many terms are needed to give the sum minus 25? So Sn is given as minus 25. Our target is to find n, which is not given. Our target is to find n, which is asked, right? So let's use the formula. Sn is n by 2, 2a plus n minus 1 d. Using this equation, I can get the value of n and substituting those values first. Minus 25 n by 2, 2a will be minus 12 plus n minus 1 times d, which is 1 by 2. This is what you have. I seem to get a quadratic in terms of n, which is okay, that's not an issue. N times n will be a quadratic. Let's rearrange all of these values. This is 2 into 2. 4 will go over here, this will become minus 100. This is n, in the bracket you will have minus 24 plus n minus 1. Okay, so that tells me n times n minus 25 is equal to minus 100. Do you observe that? Yes. The quadratic equation therefore obtained is n square minus 25n plus 100 is equal to 0. And if you factorize this, factors whose sum is 25. So 100 can be done as 20 times 5. This becomes n will be equal to 20 or n will be equal to 5. So how many terms of the AP are needed to give the sum minus 25? It is any general AP. So we can have 20 terms or we can have 5 terms. Now will we get 2 answers in this question? We are getting 2 answers, and yes, that's the correct. Both the answers are correct for this question. And I'll give a salt. Let's understand the logic behind this answer. So if you see, you're adding 1 by 2 and gradually the terms are decreasing in magnitude, right? They're increasing in value, but they're decreasing in magnitude. This observe? You observe this is minus 6, minus 11 by minus 5. After some time, you'll reach minus 4, minus 3, minus 2, minus 1. Then you'll reach a 0, right? And if you need a sum of minus 25, before 0, before you reach 0, you'll have some particular number of terms for which the sum will be minus 25, that is 5 terms. What will happen after that? After 5 terms, you will get more negative terms, then you will get a 0 and you will get some positive terms. Okay, there will come a point where these extra negative and extra positive terms will cancel each other to give you another particular value of n for which the sum is again 20 minus 25, right? That's what you will get. So cancellation of terms gives the sum minus 25 for n equals 20 as well, right? Positive and negative terms cancel to give you this. So that's my correct answer for this 4th question, as you can see over here. In the 5th question we have, in an AP, if pth term is 1 by q and qth term is 1 by p, prove that the sum of first pq terms is half times pq plus 1. P is not equal to q. Okay, prove that. Once again, we are talking about a question which says prove that. So let's write first whatever is given. Pth term is 1 by q. If it is an AP, A plus D, A plus 2D, comma dot 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 is the AP. Let this is the AP. Okay, and it is given that pth term is 1 by q. AP, which is the pth term, is 1 by q. It is also given that qth term, which is AQ, is equal to 1 by P. Prove that the sum of first PQ terms. To prove sum of first PQ terms, SPQ, is equal to 1 by 2 times PQ plus 1. This is what we are interested in, right? Okay. And how will we prove this? For SPQ, we know that this PQ is the number of terms. We just need A and common difference. And for finding A and common difference, we need two conditions. There are two conditions present over here. We can use those two conditions to get A and D, and therefore the sum. So let's start with the proof from here. AP is equal to 1 upon Q, and what does that tell me? AP will be A plus P minus 1 D, which is equal to 1 by Q. Let's call this equation 1. Let's call this equation 1. This is equation 1. What else? You have another thing over here, AQ. AQ is equal to 1 upon P. That tells me A plus Q minus 1 D will be equal to 1 upon P. Is that okay? Yes. What else? Can you solve these two equations 1 and 2 to get the values of A and D? Yes, that's very much possible. And how will we do that? So we are given two equations and two unknowns. We can easily find the values of A and D by simple elimination, right? We can subtract to give, let's say, the value of D easily, and we can correspondingly, once we get D, we can find A easily, right? Okay. So I would like to subtract, yes, but then I would like to make a small modification first. These two equations are there. I can easily subtract them, but can I also do one thing? Can I also write these two equations in this particular form? Let's multiply with this Q. This is AQ plus PQ minus Q times D, which is equal to 1. What about this? This is AP plus PQ minus P times D is equal to 1. And now let's subtract these two. Now let's subtract. Subtract these two, and subtracting these two gives me A times Q minus P plus PQ minus D is coming out common, PQ minus Q minus PQ plus P times D is equal to 0 over here. Is that okay? Yes. So PQ gets cancelled. This is P minus Q. This is Q minus P. I can take out a Q minus P common. This will be A and this will be minus D is equal to 0. And since P is not equal to Q, this is non-zero. The product of two numbers is 0, two real numbers is 0. This is non-zero. Therefore, A minus D will be 0, or that tells me that A will be equal to D. That's the first thing that you observe, that A will be equal to D. That's what you observe. Okay. Once you have noted that A equals D, can you easily use 1 or 2? Let's say use equation 1. That gives me A plus P minus 1 times D. D can be replaced with A again. This is 1 upon Q. Okay. You can take out A common. P minus 1 plus 1 is P. So AP is equal to 1 upon Q, or A will be equal to 1 upon PQ. And D is also equal to A. Therefore, both are 1 upon PQ. And now the next target. For the proof, from the point of view of proof, we need SPQ. So therefore, SPQ is equal to PQ by 2, 2A plus PQ minus 1 times D. Okay, and what will this give me? Let's take a look at this. A and D both are 1 upon PQ. So this is, let's say, PQ upon 2. A and D can come out common. This will be 1 upon PQ. And in the bracket, you will get 2 plus PQ minus 1. What is that? PQ plus 2 minus 1 will be plus 1 over here. This PQ gets cancelled with this, and what you get is SPQ is equal to 1 upon 2. In the bracket, you have PQ plus 1 as seen over here. And is this what we wanted to prove? Let's take a look at that. Is this what we wanted to prove? Yes, this is what we wanted to prove. That's the complete proof of this question, as you can see over here, using these steps, right? In the sixth question, we have, if the sum of a certain number of terms of the AP, this, certain number of terms of the AP, this is 116. Okay, certain number of terms. We are not sure how many terms. Find the last term. We are interested in the last term. Okay, let's take a look at this. Certain number of terms of the AP this. So we're talking about AP, which is 25, 22, 19, dot dot dot. The first term of this AP, A is 25. The common difference, as you can see, this minus this, which is minus 3. Right? Certain number of terms, the sum of a certain number of terms, Sn is 116. N is not known. But what are we asked? We are supposed to find the last term. An is equal to question mark. That's the main target. That is the main target. And for finding that, I have A, I have D, I have Sn. I'll find the value of n first of all. Right? Use Sn is equal to n by 2, 2a plus n minus 1 d over here. Okay. We seem to get a quadratic in terms of n. Like a few questions back, we saw quadratic in terms of n. There were two values of n, and both were correct. Here also we may get two values of n. As you see, the series, the values are continuously decreasing. So after a certain point of time, you will get some negative values, right? First you get some positive values, then you will get some negative values. So there's a possibility that the sum that you want, 116, is obtained with positive values, and after cancellation of negative values, it is obtained again after a certain point of time, right? So at two different values of n, you get the sum 116. It is possible. Let's see, let's calculate and see where does that take me. Sn is 116, which is n by 2. In the bracket you have 2a, which is 50, 25 times 2, plus n minus 1 times d, which is minus 3. What does this become? This is 232, which is n times, this is minus 3n over here, plus 3 plus 50 is plus 53 over here. Multiply this, this is minus 3n square comes over here, this becomes 3n square, plus 53n comes on the left hand side, this becomes 53n with a minus, and you have plus 232 is equal to 0. 3n square, this is 3n square, nothing else. 3n square minus 53n plus 232 is what I have. What else? Multiply 3 and 232 and factorize them to get the sum 53 somehow. So 3 into, this can be written as 2 into 116, okay, 6 into, let's write it as 3 into 2 into, what is this further, 116 can be written as 4 times, what is this, this is 28, is it? This, please take a look at this. 20 and 30. No, this is not 28, this is 29 over here. 29, yes? Yes. 2 into 4 into 3. So 4 into this is okay. And now let's take a look at these numbers. This is 4 into 8. 8 times 3 is 24. 24 and 29, is that equal to 53? Yes, 24 and 29. This can be done as 24 into 29. This product is equal to this product. The sum of these two terms is 53. So this becomes, this can be factorized as 3n square minus 24n minus 29n plus 232 is equal to 0. Factorizing this, one of the 3n will come out common. What will remain is n minus 8. And the other term will be 3n minus, what do you get over here? Can you take out 29 common from here? Yes, this is 29 coming out common. This is what you get, this equals 0. So obviously n will be equal to 8 or n will be equal to 29 by 3. Now you can observe that 29 by 3 is not a natural number, right? So this cannot be the number of terms. We may have got two answers, but as you can see that the other answer is not so good. So n is equal to 8 is the correct answer for this. But that's the value of n. We need an. Therefore, an, which is equal to a8, will be a plus 7d. What is that? A is 25, 7 is okay, d is minus 3. 25 minus 21, which is 4. This is an, which is the last term. This is the correct answer for this question. As you can see over here, that's the complete solution of 6th question. In the 7th question we have, find the sum to n terms of the AP whose kth term is 5k plus 1. Sum to n terms of the AP, okay. Kth term is 5k plus 1. Sum to n terms is question mark. Kth term, when you talk about kth, AK is given as 5k plus 1, right? And you're asked to find the sum of n terms. You're already given n basically. You just need the values of A and D. And from AK, I can easily note A1 will be equal to 5 plus 1, which is 6. A2 will be 5 times 2, 10 plus 1, 11. And therefore, A is equal to 6. D is equal to 11 minus 6, which is 5. You have A and you have D. Sn is not difficult. This will be n by 2. 2A plus n minus 1 D. This is what you'll have, right? And what is this? This is n by 2. 2A will be 12 plus n minus 1 times 5 is what you need, right? This is n times 5n plus 7 upon 2. This is the final answer for this question, yes, but is this the only way? No, there's an alternative approach where you don't have to do all of this. There's an alternative approach. What's that? Do you see that Sn has another version, that is n by 2, A1 plus An, first term plus last term, yes. And you see that we are given a formula for AK. So this is n by 2. What is A1 equal to? A1 is 5 times 1 plus 1. An is 5 times n plus 1. Okay, so this becomes 5n plus 5 plus 1 plus 1, which is 5n plus 7. There's an n already there outside and divided by 2. Obviously, you get the same answer, but instead of finding A and D, you can directly use this version and get the answer directly like this. That's the 7th question for us. In the 8th question, we are given if the sum of an AP is Pn plus Qn square, sum of n terms, Pn plus Qn square, where P and Q are constants, find the common difference. How will we find the common difference? So, common difference can be found if you know first of all An, you can easily get A1, A2, and the difference of A1, A2 will be the common difference, right? And if you know Sn, can you find An at any point of time? Yes, An is Sn minus Sn minus 1. This is an important formula which is true in general for any series for that matter. It is true for AP as well. So, Sn minus Sn minus 1. That tells me An will be equal to Pn plus Qn square minus Pn minus 1 minus Qn minus 1 square. This is what you have, right? Pn minus Pn and plus P is what you'll get over here. Yes, plus Q times n square minus n minus 1 square. This is A square minus B square, which will be A plus B, n plus n minus 1, 2n minus 1. N minus n plus 1 will be 1. This is it. So, A plus B, A minus B is what I have applied over here. What does this become? This becomes 2nq or 2qn minus q plus p. This is what you get, right? The common difference can be found by writing A2 minus A1. Difference of any two consecutive terms. So, once you have found An, this is A2, which is 2q into 2 plus p minus q, minus A1 will be 2q minus p, and minus or minus will be plus q. You see, this gets cancelled. 4q minus 2q will be 2q, and that's your common difference, 2q over here. That's my required answer for this question, as you can see over here. But one important thing to discuss over here is this. Please observe. What do we want to observe? That for AP, the sum of n terms will always be of this form. The general term will always be of this form. For an AP, the general term An will always be of the form something A plus B times n. This is a linear polynomial in n. The general term, that is the nth term of an AP, will always be a linear polynomial in n. And sum of n terms will always be of the form Pn plus Qn square. This is a quadratic polynomial in n, but do you observe that there is no constant term in this, right? So you'll always have a quadratic polynomial in n with constant is equal to 0. This is the general form for sum of n terms of an AP, nth term of an AP. Then what do we observe from here? This B is the common difference. This B is the common difference of that AP. If this is the general term, this B is the common difference of the AP. So if you observe, sum of first n terms is a quadratic polynomial. Yes, there is no constant term. The nth term is a linear polynomial in n, and the coefficient of n, this will be the common difference. Common difference, that 2q will be the common difference. Is that okay? Yes. Please take a look at this complete thing throughout. What about the first term? So first term is not difficult. That first term will be a plus b. And in this also you can find the first term easily. By the way, this and this are two different series, right? P and Q, A and B can be related among themselves by some value. But if you are given Sn, can you find the first term easily? Yes. Sn, if you find S1, that is A1 only. So P plus Q is the first term. And if you find the S value of S2, S2 will be A1 plus A2. Right? If you are given Sn, you can find S1. Sorry. What you can do is, there's an alternative approach and you can follow that. So given the value of Sn, what you can do is, why not find S1? What is that? S1 is P plus Q and this is simply A1. What is S2? S2 will be A1 plus A2. This is S2 and this is equal to 2P plus 4Q. So you know A1 and you know A1 plus A2. What do we need? Common difference is A2 minus A1. So from this you subtract this twice. Okay, so A2 plus A1 minus 2A1 is what you need. What is that? A2 plus A1 is 2P plus 4Q and minus twice of this, which is 2P, 2Q subtracted from here. That's an alternative approach of handling the same question. 2P gets cancelled, 4Q minus 2Q will be 2Q. That's my required common difference. That's another approach by which you can find the common difference over there, right? This is the first approach, that's the second approach, and this is some extra information, extra bit of information which you should be aware of. Let me get aside so you can take a look at the complete screen, yes, and that's all that you have in this 8th question. In the 9th question, we have the sum of n terms of two arithmetic progressions are in the ratio 5n plus 4 is to 9n plus 6. Find the ratio of their 18th terms. How will we do this? Let's take a look at the sum of n terms of two arithmetic progressions. So there are two different arithmetic progressions given. Let's call the two arithmetic progressions A plus D. So you know the first term and the common difference. First term is small a, common difference is small d. Let's call the second arithmetic progression so capital A is the first term and capital D is the common difference for this. Let's call this small s. Let's call this capital S. Okay. Sum of n terms of two arithmetic progressions are in the ratio 5n plus 4. So Sn upon Sn. Sum of first n terms of two arithmetic progressions are in the ratio 5n plus 4 upon 9n plus 6. Find the ratio of their 18th terms. To find A 18 upon capital A 18. And what is this actually? A 18 is A plus 17D, and this here is capital A plus 17 times capital D. Times capital D. This is what we are interested in, right? Okay. How will we approach this question? So with this given information, we can begin from this first and then move on to this one somehow. Okay. So first tells me Sn, which will be n by 2, 2a plus n minus 1 d upon n by 2 again, 2 times capital A, n minus 1 times capital D is equal to this 5n plus 4 upon 9n plus 6. Okay. So seeing this, obviously n by 2 gets cancelled, and we are interested in this. So let's create small a and capital A by dividing with 2 here as well as here. Okay. So we can divide by 2, and that gives me a plus n minus 1 by 2 times small d. Capital A plus n minus 1 by 2 capital D is equal to 5n plus 4 upon 9n plus 6. And the important thing at this stage is that I can put any particular value of n in this and in this. The equality will hold, right? So any value of n can be substituted. What value of n are we interested in? We are interested in a plus 17d upon capital A plus 17 times capital D. So n minus 1 by 2 should be equal to 17. N minus 1 by 2 should be equal to 17, or you can say, okay, n minus 1 by 2 is equal to 17. That's what we are interested in, right? So n minus 1 equal to 34 and n equals to 35 is what we are interested in. So next what you'll do is put n equals 35. And now mind you, that calculation has been done in the background. Therefore, we have reached this stage that we can put n equals 35 over here. Once you do this, what do we get? So n equals to 35 tells me a plus 35 minus 1, 34 by 2, 17 small d, capital A plus 17 times capital D is equal to, on the right hand side, n equals 35, 5 into 35 plus 4, 9 into 35 plus 6 is what you get. What does this simplify into? 5 into 35, what is that? 175 plus 4 is 179, and this 9 times 35, well, the 315 plus 6, 315 plus 6 is 321. That's what you have, right? And do these get cancelled? Maybe. But this particular value is equal to small a18, capital A18, and that ratio is 179 upon 321, or required ratio will be 179 is to 321. Let's see whether these get cancelled by some particular factor. I don't think so, but we'll just confirm. 179 is to 321. So 179 does not divide by 3. 4 is irrelevant. 5 is also irrelevant. 6 is irrelevant. 7 is 7 relevant. For 321 or for 179, let's take this 179. 7 and then 49. Is it? No, this is not relevant. 8 and 9 are again gone. 10 is gone. 11. 11 is okay? No, 11 is also not okay. What about the other odd numbers over there? 13. Is 13 okay for this? No, 13 goes with 169. And we don't need to go beyond that. Up till 13 is okay. So this is the required ratio. 179 is to 321. Ratio of their 18th terms is what we have found over here. That's the final answer for this question using this approach. That's the final answer. In the 10th question, we have, if the sum of first p terms of an AP is equal to the sum of first q terms, then find the sum of first p plus q terms. Okay. Given. sum of first P terms is equal to sum of first Q terms of an AP. This sum of two find S of P plus Q question mark. That is required, right? Okay. Let's talk about the solution. So let AP is A plus D, A plus 2D, comma dot dot dot. This is what we have. Since SP equals P by 2, 2A plus P minus 1 D. This is what you have. SP. And what is SQ? This is Q by 2, 2A plus Q minus 1 D. This is what you have. SP and SQ are given, right? And what do we need? S of P plus Q. And what is that? This is P plus Q by 2, 2A plus P plus Q minus 1 times D. So if you observe carefully, we need the values of A and D both. Okay, this and this are given equal. So at max what we can do is we can find a relation between A and D. Yes. Let's try to find a relation between A and D somehow. Let's see. So how will we find that? We have 1 and we have 2. There are two equations. We can simply subtract these two. 1 minus 2. And that tells me, okay, SP and SQ, they're equal. So the left hand side becomes 0. What about the right hand side? In the right hand side, I have P by 2 into 2A, which is PA, Q by 2 into 2A, which is QA. So for A, I'll have PA minus QA. I can take out a common and this is what you'll get. Yes. What about for D? I have P by 2 times P minus 1 times D, Q by 2 times Q minus 1 times D. I can take out a D by 2 common from here, and in the bracket what you'll get is P times P minus 1, which is P square minus P, Q times Q minus 1, which is Q square minus Q. This is what you'll be interested in. Okay. A or 0 is equal to A times P minus Q plus D by 2, and you observe that P square minus Q square, I can write it as P square minus Q square minus P plus Q in this manner. Yes. This can be factorized at P plus Q, P minus Q, and I can take out a minus common, P minus Q will remain. So P minus Q from here, P minus Q from here, and P minus Q from here can be brought out common. Yes. Okay, and can I take out a 2 also common from here, from the denominator? What is remaining over here is 2A. D times what will remain over here is, please observe, P plus Q will come from here and there will be a minus 1 over here. This is what I am getting. This whole expression is equal to 0. Yes. Okay. Now do you see the answer? Very close. Yes. Sum of first P terms of an AP is equal to sum of first Q terms. The person should have mentioned, although the person should have mentioned that P is not equal to Q, but you observe that sum of P terms is equal to sum of P terms, so that will not be any condition. For here, S of P is equal to S of Q implies that P is not equal to Q. And since this is non-zero, the product of these two is 0, therefore this will be 0. 2A plus P D times P plus Q minus 1 will be 0. This is 0. And therefore S of P plus Q, what about this one? This is nothing but P plus Q by 2, 2A plus P plus Q minus 1 times common difference D, and since this bracket is 0, this overall value will also be 0. That's my required answer for this question over here, as you can clearly see. So subtracting these two was important. Once we found the value relation between A and D, things become very simple after that. That's all that you need in this 10th question. In the 11th question, we have sum of first P, Q and R terms of an AP are A, B, C respectively. Prove that. We are supposed to prove some complicated expression over here. Sum of, the person is saying, sum of the first P terms, Q terms, R terms of an AP are this. So SP is equal to A SQ is equal to B, SR is equal to C. This is given, right? And we are supposed to prove something. We'll prove that, but first let's write these expressions. SP is equal to A. This will be P by 2 times first term. Let AP is A plus D, comma dot dot dot. Since we have already used small a, we cannot use small a for the first term. Let's use capital A plus capital D. So this is 2 times capital A plus number of terms P minus 1 times capital D. This is the value of small a. What is the value of small b? This is Q by 2, 2a plus Q minus 1 times capital D. What is the value of small c? This is R by 2, 2a plus R minus 1 times capital D. This is what we have. Is that okay? Yes, that looks pretty much okay. Sum of first P, Q and R terms of an AP are A, B and C respectively. Prove that A upon P times Q minus R, B upon Q times R minus P and C upon R times P minus Q. That's what we are interested in? Yes. So let's focus on A upon P, B upon Q and C upon R. That can be found easily, yes. And A upon P is equal to this complicated looking expression, but we can multiply that with Q minus R and see where does that take me. Yes, yes. So now in that expression, LHS is equal to A upon P, or what we can do is, let's do one more thing. Let's multiply A upon P with Q minus R in this expression only. Okay. Instead of writing the LHS, because that will be a long expression, what I'll do is A upon P, this is A upon P times Q minus R. Therefore, this is equal to, with the help of this first one, this is equal to, you have A over here, 1 by 2 goes inside, Q minus R times 1 by 2, in the bracket you have 2A plus P minus 1 times capital T. This is what you have. Okay, and what does that give me? Okay, this will be A times Q minus R plus P minus 1 times Q minus R times D by 2. Please take a look at this. This is what you get. This expression is equal to this. Half times Q minus R multiplied by 2 will be this. Half times Q minus R multiplied by this will be this expression. Now, the next expression, B by Q times R minus P. Similarly, will be A times R minus P plus Q minus 1 R minus P times D by 2. This and C. C by R times P minus Q will be equal to A times P minus Q plus R minus 1 times P minus Q times D by 2. And now we can add these three, right? Adding. Let's call this 1, 2, 3. They will become 4, 5, 6. So adding 4, 5 and 6, what you get is A by P times Q minus R plus so and so terms dot 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 will be equal to capital A times Q minus R plus R minus P plus P minus Q. You see, all of these are in cyclic order, right? So they will get cancelled. Yes, so coefficient available will become 0. Similarly, for plus D by 2, what do we have? You have P times Q minus R, P times Q minus PR, that's what you have, and you have minus Q plus R first of all, right? Multiplying these two, there will be 4 terms. QR minus QP and minus R plus P is what I have. Then you have plus RP minus RQ and minus P plus Q. There will be 4 terms. I have written them in this manner so that you can easily see them getting cancelled. PQ minus PQ, QR minus QR, PR, PR, Q, Q, P, P, R, R. everything gets cancelled. Yes. So that tells me A by P times Q minus R plus B by Q times R minus P, this term, plus C by R times P minus Q. This whole left hand side is equal to 0 on the right hand side. That's what you see with this, and this is what we wanted to prove, right? That's the complete proof of this question, as you can see over here in this solution. That's all? Yes, that's all for this 11th question over here. In the 12th question, we have the ratio of the sums of m and n terms of an AP is this. The ratio of the sums of m and n terms of an AP is this. Show that the ratio of the mth and nth term is this. Of an AP, we are looking at one particular AP, right? So let AP is A plus D and dot dot dot. It is given. Sum of m and n terms, the ratio is m square upon n square, and prove that. To prove, what are we supposed to prove? Ratio of mth terms and nth terms is equal to 2m minus 1 upon 2n minus 1. This is actually one result which you can maybe remember as well, that if the sum of m and n terms of one particular AP are in this ratio, then mth and nth term will be in this kind of a ratio. How will we prove this? Let's talk about the proof. For the proof, we can begin with this one, right? Since we are talking about the same AP, the first term and the common difference will be same. So Sm upon Sn is equal to m square upon n square, which tells me, okay, this is m by 2, 2a plus m minus 1 d upon n by 2, 2a plus n minus 1 d, which is equal to what? We have written Sm, we have written Sn, and this is equal to m square upon n square. Is it not? Yes. What are we interested in? We are interested in am upon an, which is equal to what? This is also equal to a plus m minus 1 d. A plus n minus 1d. Keep a look out for this kind of an expression. We need to form this kind of an expression, right? So this particular thing will be simplified to what? M by 2. So 2 and 2 get cancelled. M from m square, n from n square will get cancelled. And this is this. So you divide with 2, you get a plus m minus 1 by 2 d upon a plus n minus 1 by 2 d, which is equal to m upon n over here. This is important, right? This is important. And from here, I need to reach this particular point. So basically, this m and this n can be replaced by anything, right? Okay, we can put some particular values, let's say 5 or 6, we can put 10 or 12. So can we also put such a value that this m minus 1 by 2 transforms into m minus 1? And this n minus 1 by 2, we put set a value of n such that this transforms to this. So m minus 1 by 2 is equal to this. This is 2m minus 2 plus 1 will be 2m minus 1. Okay. So we do this calculation in the rough. M minus 1 by 2 has to be replaced with m minus 1. So this m over here, this is question mark. This m minus 1 will be 2m minus 2 will be replaced with this. M will be replaced with 2m minus 1. This m will be replaced with this. So now, once you have done that calculation, m is replaced with 2m minus 1 and n is replaced with 2n minus 1. Replace. Because this is true for all values of m and n on the left hand side and right. This tells me, okay, this becomes a plus 2m minus 1 by 2 d, a plus 2n minus 1 by 2 d. On the right hand side, this becomes 2m minus 1, 2n minus 1. This is what you get. Okay, and what is this equal to? A plus, this becomes m minus 1 d. This becomes a plus n minus 1 d. And that is equal to 2m minus 1 upon 2n minus 1. What is this equal to? This is nothing but mth term. Nth term is equal to 2m minus 1 upon 2n minus 1. That's what we wanted to prove, and that's the complete proof of this one, right? So the important thing is this step over here. M is replaced with 2m minus 1. When you are given the sum of n terms and the ratios, so for getting the ratio of nth terms, you replace m by 2m minus 1. That's what you do. Right. That's the 12th question for us and the proof of this complete question. In the 13th question, we have, if the sum of n terms of an AP is this plus this and its mth term is 164, find the value of m. Okay. Sum of n terms of an AP, Sn is 3n square plus 5n. Okay. And Am is given 164. Find the value of m. M is equal to question mark. This is given and this is asked. How will we do that? We can always write the nth term easily given the value of Sn. An will be Sn minus Sn minus 1. Let's write that. This is Sn will be equal to 3n square plus 5n minus 3 times n minus 1 square minus 5 times n minus 1. 3 can come out common, n square minus n minus 1 square. This is a square minus b square. This will be a plus b, a minus b, n minus of n minus 1 will be this. Plus 5 times n minus this will be 1. Okay, so this becomes 3 times 2 is 6n, minus 3 plus 5 is plus 2. This is an for us. Okay. Now, am will be 6m plus 2, which is given as 164. This is given. This tells me, okay, 6m will be 162 and m will be equal to what? 2 and 7. That's what you get. M will be equal to 27. That's the correct answer for this 13th question. Important thing, this is the formula which is important. Right? Very easy, very simple. And that's all that you need to do in this 13th question. For 14th question, we have insert 5 numbers between 8 and 26 such that the resulting sequence is an arithmetic progression. So we need to insert 5 arithmetic means basically, right? We have 8, A1, A2, A3, A4, A5, 26 in AP. This is important. 5 numbers have to be inserted such that this resulting sequence is an AP. Right? Okay. So the first term is 8. Okay. The last term, this is 5 plus 6 plus 1, 7. A7, which is the last term. This is the last term, which is 26. So I can replace this with a plus 6 times common difference. And that tells me, okay, 26 will be equal to 8 plus 6 times common difference. Or common difference will be b minus 8, 26 minus 8 upon n plus 1, which is 6, sorry. 6. What is this equal to? 26 minus 8 is 16 upon 6. 16 upon 6. And can I simplify this as well? This is 8 upon 3. This is common difference d, which is 8 upon 3. Now, in general, when we get this kind of an expression, so for inserting n arithmetic means a1, a2, dot 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 up till an, between two numbers a and b, if you want to insert this, the common difference can easily be found as b minus a upon n plus 1. You observe, 26 minus 8 upon number plus 1, that is 6. 26 minus 8 upon 6. This is common difference, right? That's the approach which you can follow to get that, right? So in general, that is something which is useful for you. But here in this question, this is the value of d. Now, can you find the 5 numbers? A1 will be a plus d, which is 8 plus 8 by 3. What is that? 32 by 3. A2 will be a1 plus d. Add a d over here. This is 40 by 3. Then you will need a3, which is 48 by 3. a4 will be 56 by 3. a5 will be 56 plus 8, 64 by 3. This is what you'll need, right? Is that okay? Yes, that's okay. Just a minute. 26 minus 8 will be 18 by 3, 18 by 6, not this. Gee, let's make that correction. This is 9 by 3. This is small correction over here. Yes, 16 by 3 will not be the case. This is 18 by 3, which 18 by 6, which is 3. Okay, so D is 3 actually. Yes, and this will be 3, which is 11. This will be 11 plus 3, which is 14. Then 14 plus 3 will be 17, and 17 plus 3 will be 20, and 20 plus 3 will be 23. How did I guess that? Okay, because after adding an 8 by 3 in the previous one, I was getting a 24, not 26, right? So there was some error in the calculations, and therefore I could check that, right? Arithmetic progression questions are relatively easy. So these are the 5 numbers. 5 numbers? Yes, therefore 8, 11, 14, 17, 20, 23, 26 are in AP. Now this is easy, right? So the 5 numbers are, these are the 5 numbers up till 23. That's my correct answer for this question, 14th, as you can see over here. In the 15th question, we are given if a power n plus b power n upon a power n minus 1, b power n minus 1 is the arithmetic mean between a and b, then find the value of a, find the value of n. Yes. Arithmetic mean between a and b is equal to a plus b by 2. That is something which we know, right? Or it is given that, given a plus b by 2, this arithmetic mean is equal to this, a power n plus b power n upon a power n minus 1 plus b power n minus 1. So one is a simple comparison. What you can do is, you can see that this becomes 2, and since a power n is equal to a, okay, we can simply compare and say n seems like 1. So putting n equal to 1, this will be a plus b. This will be a power 0, b power 0, which is 2. So n equal to 1 satisfies this, right? That's one of the ideas which you can follow. But then in general, is that the only value of n? So we'll have to do some calculations with this and see where does that take me. So one idea is clear, okay, at this stage you can say that n equal to 1 is the solution. Let's solve this. Multiplying these two, this is a times a power n minus 1, which will be a power n, plus a b power n minus 1, plus b a power n minus 1, plus b power n, which will be equal to 2 times a power n plus 2 times b power n. This implies, okay, that after cancelling out the a power n and b power n, you get a b power n minus 1 plus b a power n minus 1, a power n minus 1. Let's note that carefully. This power n minus 1 will be there. Minus a power n minus b power n, when you take everything on the left hand side, this is what you get, right? What else? What else? So that further tells me, between this and this, can I take out b power n minus 1 common? Yes. What remains is a minus b. Yes. Between this and this, I can take out a power n minus 1 common. What remains is b minus a, and this is equal to 0. Can you take out a minus b common from this complete expression? Yes. So that gives me a minus b times b power n minus 1. And a minus b will be minus of this. So minus a power n minus 1 is equal to 0. Now the product of these two expressions, if that is 0, then this implies either a minus b will be equal to 0, or this implies a equals b, or b power n minus 1 is equal to a power n minus 1, which tells me a upon b power n minus 1 will be equal to 1. This is what you get. Now something power n minus 1, if it is equal to 1, that tells me that n minus 1 will be equal to 0, or a upon b, this ratio is equal to 1. Okay. This tells me a equal to b or n equals 1, or you can say a equals b. Now a equal to b is obtained there also, right? So therefore either n equals 1 or a equals b works in this case. This or this. And if this is not the case, if a and b are two separate numbers, two different numbers, for writing the arithmetic mean, if they are two separate numbers, then we can say that n equals 1. If a is not equal to b, then we can insert an arithmetic mean, right? Only then we can insert an arithmetic mean between a and b. If a is equal to b, then the arithmetic mean will be that particular number only, right? So if a is not equal to b, then we can say that n is equal to 1 is the correct answer. So that's the only thing that you obtain. Oh, you said that n equal to 1 is the answer directly as well. Yes, but this is how you'll approach this question and prove in general, right? Find the value of n in general. This is how you will solve this kind of a question in general, right? That's the complete solution and final answer of this question number 15th, as you can see over here. In question number 16th, we have between 1 and 31 m numbers have been inserted in such a way that the resulting sequence is an AEP. Resulting sequence is an AEP and the ratio of 7th and m minus 1th numbers is 5:9. Find the value of m. Okay, between 1 and 31, m numbers have been inserted. Let's call them a1, a2, ... am, and you have 31 after that, right? This is what you have. Resulting sequence is an AP. This is an AP. And the ratio of 7th numbers given, a7, am minus 1 is equal to 5/9. Find the value of m. Okay, that's something which is there. So arithmetic progression, if first term is known and this is the last term, can I find the common difference easily? Yes, but we don't know m, right? Okay, so can we find the common difference using some other approach? Because we are supposed to find m, right? With these, I can get m and I will get an equation which has both m and d as unknowns. So this particular equation has to be simplified to maybe give us another equation in terms of m or d. That's what we are looking at, right? That's what we are interested in. Let's take a look at these numbers. A7, what will A7 be equal to? This will be first term plus, if this is A1, A1 is first term plus D. A2 is first term plus 2D, 1D, 2D. So 7 will be 7 times common difference. A7 will be 1 plus 7D. Please take care of that. This is important to note. Similarly, m minus 1 will be 1 plus m minus 1d, but that gives m minus 1 and d both in here. Do you see that am and am minus 1 can be obtained by moving back from 31 as well, right? So you add a d, you move on the right, you subtract a d, you move on the left, and once you observe that, can you see that am minus 1 will be 31 minus d, which is 31 minus 2d. Do you observe this? This is the important thing. We can solve by creating two equations in terms of m and d, but why? Why not create a single equation in terms of d? This. Think in these terms, and if you can do that, then a7 upon am minus 1 will be 1 plus 7d, and this will be 31 minus 2d, which is equal to 5/9. This is 9 plus 7 times 9 is 63d, which is 155 minus 10d, and that tells me, okay, 73d is equal to 155 minus 9 is 146, or that tells me d will be equal to 2. You find the value of d. And now I can easily get the value of m. Now 31 is equal to 1 plus number of terms m plus 1 minus 1 times d, which is 2. D is 2. That tells me 30 is equal to m times 2, which tells me m is equal to 15. Is the correct answer for this question number 16th, as you can see over here. This is the important key. Otherwise, what we'll do is we can get one relation between m and d using this and this. You can get one relation between m and d, another relation between m and d using this equation. Solve them to get the values of both m and d as well. This is easy calculation, right over here. This is question number 16 for us. Question number 17 says a man starts repaying a loan as first installment of rupees 100. If he increases the installment by rupees 5 every month, what amount he will pay in the 30th installment? Amount in the 30th installment is being asked. So let's see what the installments look like. Repaying a loan as first installment of rupees 100, first installment of rupees 100. The next installment by rupees 5, 105. Then you have 110, 115. Okay. So this looks like an arithmetic progression. Yes. What amount he will pay in the 30th installment? So this is installment 1, A1, A2, A3, A4, and correspondingly A30th is equal to question mark. That is being asked. Right, we are interested in A30th. That's the 30th term of this arithmetic progression. Yes. First term is 100. Common difference is 5. Therefore, A30th will be A plus 29D. Yes or no? Yes. What is that? This is 100 plus 29 into 5. This is 145 plus 100 is 245. This is what you have. So 30th installment is equal to rupees 245. That's my correct answer for this question over here. What amount will he pay in the 30th installment? Rupees 245. That's the correct answer for the 17th question, as you can see over here. In the 18th question, it is given the difference between any two consecutive interior angles of a polygon is 5 degree. Consecutive interior angles of a polygon, the difference is 5 degree. Smallest angle is 120 degree. Find the number of sides of the polygon. Okay. Is there something missing in this question? On the first look, looks like there's something missing. But then the person says a polygon and he talks about interior angles of the polygon. So let's draw this polygon over here. Let's see. So the sides or the angles for that matter, let's call this angle 1, this angle 2, this angle 3, and so and so. This is the nth angle, let's suppose. Right? This is the nth angle. Okay. We can call them theta 1, theta 2, theta 3 as well, because angles are denoted by theta. So you can call this theta 1, theta 2, theta 3, and correspondingly theta n. The important thing to note over here is that between any two consecutive interior angles of a polygon, difference is 5 degree. So between any two consecutive, difference is 5 degree, and smallest angle is 120 degree. Let's call this theta 1 as the smallest angle, 120 degree, and the difference will be 5 degrees, so this becomes 125 degree. Okay, and so on and so forth. Right? Since 120 is the smallest angle, the next angle will be bigger, the next angle will be bigger. You would say, okay, sir, is there some issue in this? Yes, there's one small issue in this. The differences will be 5 degree, 5 degree, 5 degree, but at this stage, you will reach an angle which is very large, right? And just after that, between these two consecutive angles, the difference will not be 5 degree. Completely agree with that. But we can live with that kind of conclusion, right? We have that in mind, but differences between all of these angles up till this stage is 5 degree. Between these two, it is not 5 degree, it will be different, right? Okay. Find the number of sides of the polygon. So, number of sides is equal to number of angles, right? This is first side, second side, third side, fourth side, fifth side, and nth side. So, number of sides is also equal to n, which is question mark, right? Okay. What else do we know about these? We know first term, common difference, and we are asked the number of terms But there is a need of another particular information. What is that information? Are we missing something? Let's read the question again. We are not missing anything as such. But since it is a polygon, do we know the sum of interior angles from somewhere else? Not from arithmetic progression, but some other concepts. Yes, 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 yes. Sum of all interior angles of polygon is equal to what? Various triangles, right? Any two sides will give a triangle, right? And any extra side will give another triangle. So what you'll have is, this is n minus 2 times 180 degree. 180 degree. This is what you have, right? Yes. Okay. What else? What else? Since you know this sum of all interior angles, you can easily say, therefore, 120 degree plus 125 degree plus 130 degree plus dot 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 plus theta n is equal to n minus 2 into 180 degree. Can you say that? Yes. And what is the sum equal to? Sum is number of terms by 2. Since this is an arithmetic progression, 2 times 120, which is 240 degree, plus n minus 1 times common difference, which is 5 degree, and this is n minus 2 times 180 degree. I hope that's okay. Yes, that looks pretty simple. We have an equation in terms of n. Can we solve this equation to get the value of n? Yes, we can. Let's do it. This 2 can be brought over here. This is 240 degree times n. Now let's forget those degrees. You know, this is a degree term, this is a degree term, this is a degree. Some units are consistent, right? And n is a number after that. So let's forget those degrees. This is 240 n. It will not make a difference, therefore. Okay, 240 n plus 5n times n minus 1, which is 5n square minus 5n is equal to 180 times 2 is 360 n minus 720. This is what you will get. Okay, let's write it as 5n square. 240 and 360 will be minus 120, minus 5 is minus 125n and plus 720. This is the equation that we are getting. Can we divide with 5? Yes. So simplified form will be n square minus 25n plus, what is this? 1, 22 will be 4, 4. Okay, 144. So factorize this 144 to get the sum 25. It's simple. 144 is 12 into 12, but 12 plus 12 is not 25. So we can go, we need to increase the sum, right? So 12, you can reach 9, and 9 into 16 is also 144. So this 9 plus 16 is 25. That tells me n will be equal to 9 or n will be equal to 16. So there are two possible polygons for which we'll have the similar condition. Seems so. But I'll tell you that one of these answers is wrong. Why is that wrong? And which answer is wrong? There should be some reason for that, right? Yes. Do you observe that all of these are interior angles of a polygon? Yes. Let's see. What will be the biggest angle in case of n equals to 9? So the biggest angle in case of n equals 9 will be 120 plus 9 minus 1 times 5 degree, which is 8 times 5 is 40. 40 plus 120 is 160 degree will be the biggest angle in this case. In this case, the biggest angle, largest angle, or theta n will be equal to 160 degree. In this case, 16 minus 1 is 15 times 5, a plus n minus 1d. So 16 minus 15 times 5 will be 75 plus 120. 75 plus 120 will be 195. In this case, it will be 195 degree. 195 looks okay, it will be a convex angle, but that's not an issue. My concern is different. My concern is that if you go from 120 and you reach 195, you would have reached, this angle would be 190. Yes. This angle will be 185. Yes. This angle will be 180 degree. A 180 degree angle, what does that look like? Oh, if this is 185, then if this is 180, or you could say that this is a 180 degree angle means that it will be on a straight line. Yes. So will that be an interior angle of polygon? For any polygon, do you have 180 degree as interior angle in any case? The answer is obviously no. You don't have 180 degree angle because this is 180 degree, right? So for any polygon, you don't have 180 degree as interior angle. You just jump from here to here. Okay. So is this 195 degree okay? No, this is not okay because of that. 180 degree is not a possible angle for a polygon, right? So 195, this n equals 16 is not okay. N is equal to 9 is okay, and therefore n is equal to 9 is my final answer. With proper understanding and logic, then n equal to 16 is incorrect. That's the correct answer for this question number 18th, as you can see over here, right? With this, we come to the conclusion of this particular exercise from the chapter Sequence and Series. Till the next video, all the best.